Okay, so maybe we can start. So let's start with introductions. I'm Avinash Agasti. Hello everyone. I'm a PhD scholar in control and optimization under Dr. Bharat Bukkaji and Dr. Vishwanath Reddy. And my area of work is currently we can say differential games. Yeah. So so I will be the TA for this control engineering problem solving sessions, the live sessions that is.
Sir, please speak loud, sir.
Okay. So is it fine now?
Yes, sir.
There seems to be some problem with this microphone. Okay, so in these live problem solving sessions of control engineering, what I plan to do is I'll come prepared with some set of questions that will try to capture the essence of what has been taught in the corresponding week. But apart from like acting as a guideline for what we can do in the 1 hour session that we have, I am completely open to any new ideas, and I want this to be as interactive as possible. So whenever I'm discussing something, if you have any doubt, maybe you can chat, like type in the chat box, or you can unmute yourself and ask any question at any moment if you are not able to follow the process at any point of time. So we'll start the problem solving sessions, like the problems, in a few more minutes, and maybe till then we can find out a little more about the audience. So can you guys type down which background are you from? Like, are all of you from electrical engineering or other like mechanical and stuff? So if you do not mind, maybe you can type it down. Okay, so Venkata is from Triple E. Okay, ECE, ECE, electrical. Okay, so it seems to be dominated pretty much. Okay, we have one mechanical guy. Engineering physics, interesting. Mechatronics, ECE. Okay, thankfully we have such a lively audience so that we get a prompt answer. Okay, I expect this level of interaction throughout the sessions as well. And okay, so and if any of you can, maybe you can unmute yourself and speak a little about what you expect to learn from this course, or why you joined into this course. What do you expect to know from control engineering? If one of you can unmute yourself.
हेलो सर, मेरा नाम अभिषेक शर्मा हुआ सर और मैं बिहार से हूँ और डिप्लोमा पास आउट हूँ सर। और मेरा ये कोर्स में जॉइन होने की ये वजह था कि सर कि मैं ये आईएएस का तैयारी कर रहा था, जिसकी वजह से मेरा बेसिक कंसेप्ट तो सही है सर, लेकिन इस सब्जेक्ट को मुझे मजबूत करना था। और मैंने ऑलरेडी पहले से ही इस सर का वीडियो लेक्चर देख चुके थे यूट्यूब पर, बट असाइनमेंट जिसका मैं नहीं सॉल्व कर पाया था। लेकिन इस बार ज्वाइन होने से मुझे ये और जो भी मैंने असाइनमेंट से प्रॉब्लम है पिछले साल से वो क्लियर हो जाएंगे। और बस इतना ही, थैंक यू।
Okay, thank you, Abhishek, for sharing your thoughts. And I hope speaking in English is not an issue. Like understanding what I'm saying is not an issue, or should I keep it between English and Hindi?
नो सर, इट इज
It is fine.
इंग्लिश समझ में आ जाता।
ठीक
ये
है.
ओके सर।
Okay, thank you, Abhishek. Okay, then maybe we should get started with the questions. Okay, so let's start. So I hope all of you can see my screen.
यस सर।
Yes.
And okay, so let's start. So the first question that we have for today: in the following predator-prey model, what happens to the population of the predator, that is Y, in the absence of the prey. Now, okay, so what do we have here? We have a set of differential equations. So a differential equation in x and a differential equation in y. So usually if we have something like x dot is equal to minus ax, then we can determine the unit trajectory of x as a function of time, right, from this differential equation given some initial condition. But now in this case that we see, we have two differential equations, one in x, one in y, but the dynamics, that is the right hand side, like x dot depends not only on x but also on y, and similarly y dot depends not only on y but also on, okay, screen is not visible, is it? Is it
visible
visible?
sir, visible.
स्क्रीन विजिबल है सर.
Visible है ना राजेश? Maybe you can try to log out and log back in. Yeah, please. One more thing, if at any point this Google Meet gets cancelled, like terminated or something, just join back in the same link. I'll try to set it up again as soon as possible. Yeah, so let's get back in. Okay, x dot is, in this situation we have x dot is minus alpha x plus beta into x plus into y, that is this xy term is, so the x dot, the dynamics of x depends not only on x but also on y. So now the question is, if the predator, like the prey were to go to 0, that is x of t is equal to 0 for all t, or maybe just even take that x of 0 is equal to 0, then what do we have? Can anyone try to answer this question? What will happen if we do not have any prey in the predator prey model? No prey. So logically speaking,
They,
what do you think should
सर
happen?
then predator
when the
decay
sir,
exponentially, sir.
Okay.
Then sir predator will decay exponentially, sir.
Yeah, the predator will
yes, yes sir.
decay exponentially. Sure. So how do we get to that point? So we have that x is 0, right? So y dot equation, we have minus gamma y plus delta xy, right? So we have that x is 0. So when we start at x is 0, then at the starting position y dot is strictly dependent only on minus gamma y, as this part goes to 0, and since this part is 0, in the x dot equation, if x starts at 0, the entire thing is also 0, so x dot remains 0. That is, if there are no prey to begin with, then no new prey can come in. That sounds only logical, right? So if there were some prey, then maybe they could go down to 0 or they can go up to some other settling point or something. But in this case, since there are no prey to begin with, prey cannot appear magically in the restricted closed environment as time progresses. So the dynamics of y strictly becomes y dot is equal to minus gamma y. So what does this give us? This is a very well known solution. We have e to the minus gamma t and some constant that denotes the starting position of, like, the initial conditions of the predator. But no matter where the predator, like how many hundreds or thousands of predators we have, since we have an exponentially decaying curve, they'll soon drop down to 0. That is also a logical conclusion, because if there are no prey, predators do not have any food, any resource to go by with, so they'll exponentially drop down to 0. So I hope this is clear. If there are any doubts, maybe you can ask the questions.
Sir, what is Rotka-Volterra equation? Sir? This equation is
I think
Rotka-Volterra.
these two differential equations are called as Volterra equations, I think. Yeah. They were I think, as far as I remember, those two were working in some sort of an aquarium. Okay, Neeraj says समझ नहीं पा रहा हूँ. Neeraj, can you unmute yourself and ask which one exactly you are unable to understand? Hello, Neeraj, can you hear me?
Sir, here alpha, beta, gamma, and delta, it is a constant, sir. A constant as such, sir. Audible means
Even if they are equal, I don't.
Sir, your voice is not audible, sir.
Is it audible? Hello, is my voice audible now?
Yes, sir.
Yes, sir. Now
Yes.
audible, sir.
yes, sir.
Okay. So what I was speaking about is, as Venkata asked, why beta and gamma are not equal. I Are you asking about beta and gamma or beta and delta? Which two are you asking about? Okay, beta and gamma are not equal. Okay, so even if they were equal for this particular question, I like for this particular question, even if beta and gamma are equal, then also it doesn't change the answer. We'll just get, because x is 0, so the dynamics also stays at 0 and x does not change, and only y is the dynamics of y is dictated by this equation. So the end solution will be the same, that is the predator population will go down to 0, and I hope that is clear. And are there some other questions? How to calculate the equilibrium points of the system? Maybe we can go to that question at some point later in the course when equilibrium points have been discussed. For now, we'll just concentrate on modeling the systems and understanding the differential equations a bit better. Or maybe if you have time later today, I'll discuss that after all the questions have been covered. Okay, so let's move forward with the next question. Which term represents the loss of energy in the model equation of a lossy pendulum whose dynamics is given as this? So I guess some of you can answer this. Can I get some answers?
G by L sin theta, sir.
I'm sorry, could you repeat that again?
G by L sin theta, sir.
G by L sine theta. Okay, that's one answer. G by L sine theta.
by ml.
Are there any other answers?
Sir, b by ml square.
Just a minute. B by ml square.
Yes, sir. Yes, sir.
Okay.
B by L ml square.
Okay, then now I guess we know, we know that the pendulum model can be derived at any given theta by either by using Newton's laws or the Lagrangian mechanics. We can write mg some tension, and we can decompose the axis into the radial. Okay, can I explain the modeling system? Okay, I'll just explain this in more detail then. So we have the pendulum hanging from some fixed support with some mass at the end of the pendulum string, and this is at some angle theta. Now we'll try to get the free body diagram on the mass. mg is straight downwards, gravity. Then we have the tension in the string, which will act directly away from the mass. Now we can decompose this into a tangential direction and the radial direction, right? So by decomposing that, we have this is equal to theta, so t minus mg cos theta equal to 0, and the acceleration of the ball will be given only in the the tangential component, and that will be given by mg sin theta. So when we have, so the first equation we get the tension, and from the second one the acceleration of the mass we want to find out. Now we know that the displacement of the mass is just given by L theta. Like if it goes theta angle, if it covers theta angle, then we can say that the mass has been displaced by some L theta value. So this is the displacement. So the acceleration is basically s double dot, and that is L theta double dot. So we have this equation turns down to be m L theta double dot equal to mg sin theta. Now this gives us theta double dot okay. So this should be a plus sign instead of equal to, because we are assuming that the displacement is in positive anti-clockwise direction, whereas the gravity pulls it backwards in the clockwise direction. So this one will be plus, and we'll have theta double dot plus g by L sin theta. This is the model of a pendulum without any losses. So when we have losses, what we mean is that, so in this situation what happens is, if I have a pendulum, I pull the pendulum to some small theta say, then and if I leave it, then ideally without any losses the pendulum should be able to oscillate between those two endpoints. Like if I pull the pendulum 5 degrees and leave it, then it should oscillate between plus 5 degrees and minus 5 degrees continuously without damping down, and it should go on forever. But we know that such a system is not possible, because, and this is not possible because we have considered there are no losses. But in reality the air is a fluid and it has some viscous like damping. It gives some resistance to the motion of the pendulum, and for that only we have this extra term, and it can be incorporated into this equation to give the final lossy model. So now in this, as we saw, without losses, this is the equation of the pendulum, and this term represents the lossy component, the damping factor of the system. So whenever you see an equation of this form in general RLC circuits or mass spring systems, you would find things of x double dot plus some alpha x dot plus some beta x is equal to something, maybe 0 or some other forcing component. And whenever you see things like this, know that the alpha x dot component gives the damping factor. It is the resistance kind of thing. So in an RLC circuit, it is quite literally the resistance which dampens the energy, or else the energy would oscillate forever between the inductor and the capacitor. But on the other hand, if you have a resistor, slowly energy will be dissipated across it. So I hope this question is clear.
Sir, will you please repeat the solution?
Okay, the entire part, or do you have a doubt in any particular?
Sir, the entire part.
Okay, sure. So I'll go through these the derivation of the pendulum motion. Now I have a pendulum fixed from some fixed like support. This is the vertical line, and say the pendulum has been perturbed to some theta angle. Okay, so now at this point we will write the free body diagram for the pendulum. So it has only two forces. One is gravity acting directly downwards, and one is the tension acting away from the mass. So now we can resolve these into a coordinate axis like this, that is tangential direction and the radial direction. So when we decompose it that way, this component becomes mg cos theta and the tangential one becomes mg sin theta, right? So then we can write this equation for this axis, t equals mg cos theta, whereas for this axis, any positive, I am considering this as the positive direction and this as the negative direction. Okay, so the mass times acceleration, like the standard summation f is equal to ma equation, will give us this term. Okay, and the acceleration itself is what? We know it is the double derivative of the displacement, and for this case the displacement is nothing but L theta. So when we take its double derivative, we have nothing but L theta double dot. So the equation of the pendulum is this: ml theta double dot plus mg sin theta equal to 0. Now when we then we can reduce it, like normalize things, and these will be the coefficients. But this is the case when we do not have any air resistance. Okay, so if instead we have some air resistance which brings loss into the system, due to that air resistance an extra theta dot term comes in, because we know friction, like the fluid viscous resistance is proportional to the velocity, and here we know theta dot gives the velocity, angular velocity, but there are some L and all that terms. So when we add in the air resistance into the model of a ideal pendulum, then we get this final equation. So the question asks which term represents the loss of energy in the model equation. So this term represents the loss of the energy. I hope this is clear now, and maybe I'll type out a proper derivation step by step and share it with you guys, so that there is no confusion regarding that. Because we are short on time, maybe we can move ahead to the next question, if that is fine with all of you.
Okay, sir. Okay, sir. Okay.
Okay, now next we come to this question: which of the following is or are examples of a causal system? Now I want answers
Missile
from
guidance system.
sorry Sashi, could you repeat that?
Missile
A
guidance.
motor or generator?
Okay, I think Shashi, you answered missile guidance system.
Yes.
Okay, and what about thermostat? Is it a causal system?
Yes.
So thermostat is also a causal system. Okay, now I want you guys. Okay, Shubham asks what is a causal system. So a causal system is basically a system. So we have some input which gives out some output. In a causal system, the output at any point of time will depend only on the present input and the past inputs. That is, it won't depend on future inputs. So what can be an example of something that is not a causal system? Maybe we have a system like y of t is equal to x of t plus 1. Now in this situation it is clear that y, the output at time t, depends not at the input at any t or any past input, but it depends at the input at a future time. So if I am starting out, y of 0 will be x of 1. So the output at 0 seconds when I start out will depend on the input at 1 second. Now that is an example of a system that is not causal. So a causal system, I hope it is clear that the output,
Yes, sir, 1 and 2, sir.
I'm sorry, could you repeat that?
Yes, sir. Here the causal system is 1 and 2, sir. My missile guidance system is wrong, sir.
Yeah. So now when we look at the thermostat, what is the input? The input is the actual temperature of wherever we are trying to measure, and the output is basically like the digital reading that we have or some sort of measurement which depends on this temperature. And clearly, like the output of a thermostat, it won't depend on a temperature at some future point in time. It will always depend only on the current temperature or the past temperature. Maybe some errors would have accumulated and some of the past inputs influence the current measurement. But on the other hand, then similarly, motor or generator. Now suppose we see that the voltage is the input to the motor and let's say the velocity, angular velocity of the motor is the output. Then it is a causal system because the angular velocity of the motor will not depend on some future input. For example, if that were the case, then at some time 1, say I have not given any voltage, but as at some future time I give some voltage, then even without giving any voltage at some prior time, the motor would start turning, which is absolutely absurd, right? So a motor or a generator is a causal system. Now the interesting case of a missile guidance system. So usually how missile guidance systems work is, say I have some kind of missile and some kind of other plane that is traveling. This missile wants to hit this other plane. Then the navigation laws of the missile would be in such a fashion that it would be able to estimate where the plane is going. So in a sense, it depends on the future position of the plane. So the missile guidance system is not a causal system. Okay, so because here the trajectory that the missile has to follow, it depends on where the plane will be in the future. If the plane is somewhere here, the missile won't keep going towards this after the plane has passed, right? So the missile will always keep calculating to where the plane might go to in the future, and that is why the missile guidance system is not a causal system. Although this is a very vague and abstract way I am telling this. When we write a particular guidance law, then we can figure it out, but that is not necessary for this discussion, I hope, and if anybody wants, we can discuss it later. Now I'll move ahead to the next question. Are there any doubts for this question?
Sir, can a causal system be a static system?
Which system?
Static system.
I'm sorry, I couldn't get you. Could you type it down in the chat box? I'm sorry, x, then what is the system exactly? Can a causal system be a static system or not? A static system is, I suppose, there are no dynamics and it is fixed in time, right? Yeah, if there are no dynamics, I don't think we need to worry about what is in the past or the future, right? So I guess a static system is causal. Yeah, a static system by its definition is static, right? It has no dynamic components, no time variance, so it should be causal. Yeah. Okay, I'll move ahead to the next question. Okay, consider a system. Sorry. Yeah, all causal systems need not be static, obviously, because we saw examples of a motor. Suppose that is not a static system. That has dynamics. So yeah, all static systems are causal, but all causal are not static. Thank you, Venkata. Okay, so consider a system with some input x of t and output y of t related by the given thing. Y of t is equal to e to the power t x of t. Now the system is what?
Non-linear and convolutional.
Can you all type it down? Maybe.
नॉन लीनियर है सर और ये कॉजल सर.
Okay, I get most of the people are saying that it is a non-linear and a causal system. Okay, so what do we know about a linear system? A linear system is by definition, if we have some input, say, okay, yeah, I'll just explain the linear and non-linear system. So I have some input x1 and x2. Let's say the input x1 gives rise to the output y1 and input x2 gives rise to the output y2. Okay, so then a linear system by definition must satisfy two properties. One is superposition and one is homogeneity. That is, if instead of x1 I gave some scaled version of x1, that is alpha is some constant real number, say, then it would give me alpha y1. This property is homogeneity, and x2 okay, and next property is superposition, that is x1 plus x2 will give me y1 plus y2. This is the principle of superposition. Any system that satisfies these two properties is known as a linear system. And causal, we saw in the last question what a causal system is. So now if you take this system, y of t is equal to e to the power t x of t, right? Now if I have x1 of t giving y1 of t, okay, and x2 of t giving y2 of t, then alpha x1 of t, what does it give us? So alpha x1 of t will be the input, then by this equation, that is the system equation, we'll have y1 of t is equal to, sorry, okay, let's take x1 of t, right? For x1 of t, this system will give us what? y1 of t, which is equal to e to the power t x1 of t, right? And for x2 of t, similarly this system will give us e to the power t x2 of t, right? So now if I give alpha into x1 of t, then what do I get? I get e to the power t into alpha into x1 of t. So this is nothing but alpha into e to the power t x1 of t, that is alpha y1 of t, right? So this satisfies the first property, homogeneity. So a scaled value of this is alpha into y1. Then the next property is superposition, which you can clearly verify. If I give x1 plus x2, then I'll get e to the power t x1 plus x2, which is basically y1 plus y2, right? So this system is linear, and as we can see, it does not depend on any future time inputs, so it is causal as well. So the answer is linear and causal. Now there are some questions here, I guess. Okay, yeah. So Soumya brings up an interesting thing. X of t plus 3. Now, is it linear or non-linear? X of t.
Non-linear, sir, but I know the...
Yeah. So this system is non-linear. Why? Because if I have some y of t is equal to x of t plus 3, then when I input alpha x of t, the output y of t is not alpha times what it was for the previous case, right? So the output here will be alpha x of t plus 3, not alpha times x of t plus 3. Correct. So what seems very linear to us, the straight line, is in fact not a linear system in this definition. It is called as an affine system, which maybe you'll encounter sometime later. So I hope linearity and causality are clear. Are there any other doubts? Okay, so I'll move forward. Yeah. So we have this question. Okay, yeah. So I want to write down some equations for this circuit and eliminate I1 from the final. Okay, wait. If we take alpha is 3, then 3. I'm sorry, if we take alpha as 3, then okay, I'll take just a minute. Okay, so your question is, if I take alpha as 3, okay, just a minute. I have y of t is x of t plus 3. This is the system, okay? Now, what I want is, say x1 of t gives some y output y1 of t, right? y1 of t, which we know by the system is x1 of t plus 3. Now I want that given any alpha belong to say R, given any such alpha, if I give alpha x1 of t, then what do I get? I get alpha x1 of t plus 3, right? That is by the system equation. Any input I plug in, the output will be that input plus 3. So if I plug in alpha x1 of t, the output will be alpha x1 of t plus 3. So but this is not equal to alpha times y1 of t, right? Which was what we obtained when we gave x1 of t. So alpha times y1 of t becomes alpha x1 of t plus 3 alpha. Now these two terms are not equal. They are equal only when alpha equal to 1. But we want it to be equal for any alpha that we might wish to take. So so basically what the intuition behind this homogeneity property is, if I give some input, say I am pushing someone, then the amount he is getting displaced by, that if this pushing system is homogeneous, then if I push him by double the force, then that person will be pushed twice as far away. Okay, so that is kind of the intuition. If for linear system, if for linear system, both the principles should hold, homogeneity as well as superposition. So if I have some system where superposition does not hold, then it is not linear, and like both of them have to simultaneously hold. And a better check for that is if x1 gives x2, if x1 gives y1 and x2 gives y2, then what you can do is you can take alpha 1 x1 plus alpha 2 x2. If you find that this system like this input given to the system gives us alpha y1 plus alpha 2 y2, then you can say that the system is linear, because by taking alpha 1 x1 plus alpha 2 x2, and if that results in alpha 1 y1 plus alpha 2 y2, then you are not only like you are satisfying both the conditions simultaneously, superposition as well as linearity, homogeneity, right? So you can use this directly to check for linearity. I hope the concept of linearity, for example, y of t is equal to e to the power xt, putting input equal to 0 yields output is equal to 0. Yeah, here homogeneity has failed. Yeah, y of t is equal to e to the power x of t, that is y of t is equal to e to the power x of t. This is not a linear system, because it is neither homogeneous. When you scale it up, the output doesn't get scaled up equally, and neither does it follow superposition. E to the power x1 plus x2 is just e to the power x1 into e to the power x2, which is y1 into y2, not y1 plus y2. So this system is not at all linear. This is in fact like a highly nonlinear system. So please read my session. I'm sorry. For linear system, if homogeneity fails, should we check superposition? I guess I clarified that we do not need to if either of them fails, then the system is not linear. We can click it off right away. So these are necessary, like both of them have to be satisfied for the system to be linear. And what you have given here is y of t is exponential x of t, putting input equal to 0. We have output equal to 1. I guess I don't know why you have written equal to 0, and here homogeneity fails. That is correct. Have I answered your question? Output equal to 1. Yeah, that's correct. So here that is why homogeneity fails, and so we can clearly say that exponential is not a linear system. We need not go and check if superposition holds or not. Is that answer clear? If homogeneity fails, system is not linear. If superposition fails, system is not linear. Only if both of them satisfy, that is the system is homogeneous and follows the principle of superposition, then the system is linear. Yeah, okay. Yeah. So I hope we are all clear in linearity and causality. Now remember this.
Yes, sir.
Yes. Okay, I'll go ahead. So linearity seems like a very big restriction on the class of systems that we could have. Like almost every system you pick up would be nonlinear. Despite these issues, a linear system is a very important class of systems because of very special properties that it has. And the issue with nonlinear systems is solving them is almost impossible unless they are tailor-made to be solved. Okay. So on the other hand, linear systems always give up very beautiful and elegant closed form solutions to no matter how complicated the equation might look. If it is linear, then you'll have a closed form solution, no issues about that. But on the other hand, even a very simple nonlinear system, For example, I'll take the pendulum system that we saw. Theta double dot is equal to minus g by L sine theta. Can anyone try to solve this equation, like provide a solution for theta of t? Hello, can anyone try to solve this? Or maybe you can try to voice out your issues that you are facing when trying to solve this. Okay, I don't have any response. Okay, I'll just yeah, is my voice is audible, right? Okay, so what I am asking is, I have this equation theta double dot equal to minus g by L sine theta, which we saw was the equation for a lossless pendulum. Then can you try to provide an analytical solution, that is the solution to this differential equation, that is a theta of t that satisfies this differential equation?
Minus g by L sine theta into t square by 2.
I'm sorry, I'm having some issues with this. Can you type it down? Sorry for the inconvenience. I hope Sashi, you are saying something. Yeah, okay. Minus g by L sine theta into t square by 2.
Yes, sir.
So you are saying g minus g by L sine theta into t square by 2. This is what you are proposing for the solution?
Yes, sir.
Okay, we can try to just a minute. Okay, I'll just shorten this. So I'll just differentiate this twice then. Theta dot is no, wait, you cannot, what I'm asking for is theta of t, right? Theta is a function of t, so when I give a differential equation x dot is equal to minus ax, I say x of t is a solution and it is given by e to the minus 8t, right? So x is given as a function of time, but here you have given theta as a function of both theta and time as well. I don't think like the solution cannot be of that form, right? So maybe you guys can try this later on, but there is no closed forms. We have to find in yeah, we can do roundabout ways and all, but there is no closed form solution to this seemingly very simple equation. We just have theta double dot and just one nonlinearity sine theta, yet we are not, there exists no closed form solution for this differential equation. So that is what I mean when I say linear systems are a very important class of systems. One is because we have a solution for it, and even though what we have seen now are very simple single input single output systems, there is a bigger multi-input, multi-output systems, like you'll have more than one input, say 2 or 3 inputs, you'll have 2 or 3 outputs. Even for those systems, the solution for a linear system can be easily written in terms of in terms of analytic functions. But if we have nonlinear systems, it becomes extremely difficult to get a solution in like a function or something. There are numerical methods and stuff like that to get solutions of this, but yeah, that is why linear systems are very widely studied, and more or less throughout this course we'll focus on linear systems as well, only on linear systems. Yeah, so I'll move ahead to the next problem. Okay, so now, okay, we are getting a little short on time. Are you fine with me extending a little to discuss this problem?
Yes, sir.
Yes.
Okay, thank you.
Yes, sir.
So yeah, so this is an RLC circuit we have now. You can see this is some V of t, this is Vc of t, this is VL of t, I2 of t, I1 of t, R1, R2, C, L. So now what I want is, I want to write some equations and then maybe eliminate I1 of t from those equations and get a relationship between V, Vc, R1, R2, CL, whatever, and I2, right? So maybe you guys can, I am sure you are familiar with nodal and mesh analysis, right? Can you
Yes,
please?
sir.
Yeah. So,
Yes, sir.
so maybe you guys can try to do this by mesh analysis, maybe, so that we can
Yes,
see
sir.
if you guys can converge to a solution. Okay, so take some 3-4 minutes, then we'll discuss.
सर हेलो फर्स्ट लूप में ये फर्स्ट में इसमें केवीएल लगाएंगे सर, और केवीएल लगाने के बाद मेरा जो I1 होगा वो VT माइनस VL बाई R1 हो जाएगा, उसको एलिमिनेट कर देंगे सर.
ओके, एक मिनट, मैं KVL लगा लेता हूँ, तो फिर मुझे लगता है आई थिंक एवरीवन इज familiar with mesh analysis, so I'll just solve this, and if you have any problems maybe you can interrupt me. Then in this first loop, if I write KVL, V of t, then polarity here will be plus minus, so this will I1 of t R1, then this one will be okay, this is the first mesh equation. Then for the second one, same thing, we'll have Vc of t.
तो उसका जरूरत नहीं पड़ेगा. I1 t बराबर हम लोग लिख सकते हैं ना, VT माइनस VLT बाई R1, और वो सब्स्टिट्यूट कर देंगे I1 की जगह, तो मेरा इक्वेशन मिल जाएगा, एलिमिनेट हो जाएगा सर I1 से.
फिर से थोड़ा रिपीट कर सकते हो, मेरा माइक का
Sir,
थोड़ा ये प्रॉब्लम हो रहा है, मे बी यू कैन टाइप इट डाउन इन द चैट बॉक्स मे बी.
सर सबसे पहले तो हम लोग केवीएल लगा दिए ना सर
हाँ,
फर्स्ट मेश में, उसके बाद हम I1 को एलिमिनेट करना है, तो I1 इज इक्वल टू हम लोग लिख सकते हैं ना VT माइनस VLT बाई R1.
हाँ, इस इक्वेशन से हम I of t को बाकी के टर्म्स में लिख सकते हैं. Then the
So,
aim of this
I1
question
is
I was trying to do is, then we can write
eliminate
some second mesh equation which will have both I1 and I2. पहले वाले से I1 को बाकी के टर्म्स में लिखकर सेकेंड वाले में सब्स्टिट्यूट कर देंगे, then we'll have an equation for I2, like in terms of V, Vc, VL and I2. So if you guys can try and maybe give the answer, we'll wait for a couple more minutes, then maybe we'll
ओके
leave.
सर.
आंसर मिलने वो जो लाइक द क्वेश्चन इज, इन दोनों इक्वेशन से I1 को एलिमिनेट करना है, एलिमिनेट I1 फ्रॉम बोथ ऑफ दीज इक्वेशंस. या दैट्स द लाइक, write I1 in terms of the other things, substitute it back in the second equation, then we have it. Maybe you guys can try to solve and then we'll leave.
Yes, sir. I will get. Yes,
P of
ends.
t minus VL of t.
सर,
लूप 1 में
पहले ये केवीएल लगा दिए सर, फिर I1 इज इक्वल टू ये सोर्स वोल्टेज माइनस इंडक्टर के क्रॉस जो
अच्छा
वोल्टेज
अच्छा
है
जो
वो
आउटर लूप में, हाँ,
बाई,
दैट इज ऑल्सो पॉसिबल सोल्यूशन, यस करेक्ट.
तो वो सब्स्टिट्यूट कर देंगे सर I1 टी के जगह, ये
ठीक,
इक्वेशन 1 में सर,
बिल्कुल
तो
बिल्कुल.
मुझे इक्वेशन मिल जाएगा सर.
Yeah, so I guess you guys all pretty familiar with basic circuit analysis and stuff. So maybe we can stop here, or do you guys want to continue further?
Continue further, sir.
Okay,
कंटिन्यू सर. यस.
then I have one more question planned. Now I want to determine, first is equations at these two nodes, right? And then I want to find a transfer function between this x and this f. So first at this mass m, we can write the free body diagram. Okay, so f of t, and this spring k2, this spring, you can see that one of its ends, the one connected to mass m, is pulled x distance displacement in the right direction, while the other end is pulled x1 in the right direction, right? So net elongation in the spring we can say is x1, sorry, x minus x1. Okay, I hope this is clear. Like the spring one end is pulled x, then the other end is say pushed x1. So net thing
So,
is,
sir, for K1, sir, the force is K1 into x1 plus x2, na sir. X1 plus x, na sir.
just a minute, I'll try to get this fixed. 1 minute. Are you able to hear me now? Hello?
Yes, sir.
Hello?
यस सर.
Yeah.
यस.
So, Shashi, you were saying something?
Yes, sir, you are audible.
Yeah. For K1, sir, it may be K1 x1 plus x. No, no. See, as per the question, what we have is this point moves x1 direction towards right. Okay. So for the spring K1, what we have is its net elongation is x1 only. But for this point, for this mass m, this spring, the right end of the spring is moving x direction, while the left end of the string is moving x1 direction. So the net elongation it will have is x minus x1. Okay. So when we write the free body for this,
Sir, x1 is.
sorry, could you repeat that?
Hello.
Yeah, x1.
X1 is also in right direction, na sir?
X1 is also in right direction.
So the net will be x1 plus x, na? Because both directions are the same in the right direction.
See, okay, if I have a spring, okay, I pull the right end by say 2 centimeters, and the left end I have pushed rightwards as well, say 1 centimeter. Then what is the, okay, I'll draw it this way. Spring was there, say this is a spring, originally it was at 0 and 1, okay, or say this is 10, a 10 centimeter spring I have. Now if the right end of the spring I elongate by 2 centimeter, okay, and the left end I push it this way by 1 centimeter. So the new coordinates are 1 and 12. So now the net length of the spring is 11 centimeters, while earlier it was 10 centimeters. So now you understand, right? Net elongation is x, that is 2 in this case, and minus x1, that is 1 in this case. It is clear now, no?
Why it is minus x1, sir?
Okay, okay, just a minute. I'll do this again. I have this spring. Okay, this is at 0 centimeter. This is at 10 centimeter. Then I pulled this right end of the spring 2 centimeter. Okay, so now the right end of the spring is at 12 centimeter. So till here it is clear, right? So now the total length of the spring,
Yes, sir.
The total length of the spring is now 12 centimeter, correct? Now if the left end of the spring, like here, I push it a little rightwards till 1 centimeter, okay? So now this is 1. So now what is the net length of the string? From here to here, right? From 1 centimeter to 12 centimeter. So that is 11 centimeters, correct?
Yes, sir.
Yeah. So since that is originally how much length we had? We had 10 centimeters. Then now we have 1 centimeter extra. That is net elongation is 1 centimeter. So this is 11, but this can be written as 10 plus 2, that is the right end we pulled, then minus 1, because the left was also pushed in that same direction. So net elongation decreased rather than increasing. So I hope this part is clear. Then so this thing, then on the mass m we had a rightward force f of t, and on the left side some restoring force should be given by the spring k2. So that one, since right side we had a displacement of x minus x1 right side, the restoring force should be left side, that is minus k2 this, right? So f of t minus k2 this should be equal to mx double dot. Okay, yeah. So then we can, yeah, so this is mx double dot plus k2 minus k2 x1 minus x is equal to f of t. So this is the differential equation at the node m that we want to find out. Okay, so now I want to find out the transfer functions. So for that what I can do is, x is there, f is there, right? And we know the series combination of two springs, that gives us k effective is equal to k1 k2 by k1 plus k2. Okay, so this thing basically becomes mx double dot is the net force acting on it, that is f of t rightwards, then minus the restoring force given by the equivalent spring, right? And the equivalent spring is coming only x displacement, so that is k1 k2 by k1 plus k2 x. Now if we take the Laplace transform, we'll have s square mxs plus k1 k2 by k1 plus k2 xs is equal to f of t. Now what do I have? This I can write as, sorry, this one is also f of s, which I can write it as k1 plus k2 by m k1 plus k2 s square plus k1 k2. So this is the transfer function of the system, that is x of s with respect to f of s. Yeah, Shivraj, that is correct. Yeah. So I hope it is now clear.
So
Session.
x
Sir,
is the x is the final displacement, sir.
The one this displacement of the mass m.
Okay, sir. Then we can ignore the x1, sir.
Yeah. For getting the transfer function, we can ignore the s1. But I also wanted us to find out the differential equation we get at this node, to just to get a understanding of the spring models and stuff.
सर एक बार इसे नोडल एनालिसिस से सॉल्व कर दीजिए.
ये नोडल एनालिसिस से सॉल्व करेंगे तो ओके. नोडल एनालिसिस से सॉल्व करके क्या पाना चाहता है?
ट्रांसफर फंक्शन से.
Okay, transfer function. Transfer function, see, for finding the transfer function, even if we use nodal analysis, the good thing is we can smush this into a new spring. Is that just a minute? Is a transfer function dependent on the? I'm sorry. Your question is transfer function dependent on dependent variable or input variable? The transfer function is basically the ratio of the output to the input. So it kind of gives us what the system is. Yeah, it does not depend on the input variable. It is the ratio of the. So if I have a system, the transfer function basically gives us the characterization of the system. So it does not depend on the input. No matter what input you feed into it, it will get multiplied by the transfer function to give us some output. So the transfer function is essentially independent of the input variable. Okay, now if we solve this with nodal analysis, then also this will decompose, like boil down to some k effective given by k1 k2 by k1 plus k2. Then we have this k effective this is f of t m and this is x. So this you can see that mx double dot is equal to f of t minus k effective x. So this is, we directly get that equation that we got here, this one.
Sir,
Huh.
hello, sir. Can we write the nodal equation without ignoring the x1 and x2 and k1 and k2?
Without ignoring, like keeping k1 and k2 fixed, is it?
Keeping x1 and x also and k1 and k2 also.
Okay, I'll do that. 1 minute. Oh, sorry. This is
Yes, sir. Like this, sir. Can we write, sir?
so yeah, we can't write this. Now you need to write another equation at this node, correct? So basically, like nodal analysis is just a way to make it convenient to solve the spring things. But if you are clear in the physics of the like spring mass system, then you can like at this node, what do we have? The first spring k1 is being pulled to the right, so it will have a force to the left, and k2 will now assume that this it is pushed x1 from this node's perspective. It is pushed x1 while the end is pulled x, right? So we will k1 k2 x1, right? So we'll have k1 x1 plus k2 x1 is pushed x1, yeah. So x1 minus x is equal to 0. This is the second equation that we'll get. So when we put x1 from this equation, what will we have? K1 plus K2 x1 is equal to K2x, right? So when we will plug this value of x1 into this equation, then we'll get the entire equation, right? So okay, I'll just do it. From the previous one we obtain K1 x1 is equal to K2x by K1 plus K2, and here we had the first, when we wrote the node equation at the mass m, there we had mx double dot equal to f of t minus K2 x minus x1. I hope that is correct.
सर नेक्स्ट स्लाइड में से वहाँ पर सर K1 x1 इज इक्वल टू होना सर K2 इंटू x1 माइनस x. नेक्स्ट स्लाइड सर.
This one.
यस यहाँ K1 x1 इज इक्वल टू K2 x1 माइनस x होगा ना सर. आप यहाँ पर प्लस किए हुए सर K1 x1 प्लस K2.
वो एक्चुअली अभी हम जो इक्वेशन लिख रहे हैं, वी आर राइटिंग इन फ्रॉम पर्सपेक्टिव ऑफ दिस पॉइंट. Okay, so from this point's perspective, it is like the second spring is being pulled towards the right. Okay, मतलब हम जो पहले देखे थे वो जो स्प्रिंग था 0 to 10, यहाँ 12 को आया, फिर यहाँ 1 को आया. Although there is net elongation, but from this point it is like it is being pushed towards the right. Okay, so when we write it from this point's perspective, this will be the spring equation. Okay, maybe you can try this later, and if you do not get, you can contact me anytime, either through mail, or I think you are there in the WhatsApp groups as well. So yeah, so what I want to say finally for this one is, we can write the equations at the nodes, or we can write by like decomposing the K1 and K2 together, and the entire state equation, like the entire system equation as well.
Where is the link?
I'm sorry, your voice is breaking. Could you? Hello.
सर हम लोग एक व्हाट्सएप ग्रुप बनाए थे, अगर उसमें आप ज्वाइन हो जाते तो हम लोग के लिए बेनिफिट रहता.
हाँ, वो मैं ज्वाइन हो चुका हूँ शायद.
For WhatsApp group?
जो just a minute, let me check. NPTEL control engineering वाला ना?
यस सर.
हाँ, I'm a member of that group. Yeah. Yeah, I'll just put down my WhatsApp contact number here as well, if any of you need. And mail ID as well. Okay, so yeah, so let's leave this question for now and go through what we did today. So we went through a few questions that helped us see how we can model and how to get a little bit around the models, and how to do some analysis given some conditions and stuff, or how given a physical system, how we can derive some differential equations which act as a mathematical model for the system and capture its dynamic behavior. Okay, so I hope what I discussed today was clear. If you have any doubts with that, you can either contact me on WhatsApp or mail. And yeah, I hope I helped you understand this part a little better. And if you have any
Sir, mass average represent between node and reference है कि mass can be also be represent between nodes.
Mass सॉरी क्या फिर से क्वेश्चन?
सर जब नोडल एनालिसिस करते हैं सर तो मास हमेशा नोड और रेफरेंस के बीच में ही रहता है सर कि दो
हाँ
दो नोड के बीच में मास हो सकता है।
दो नोड के बीच में मास हो सकता है इन बट नहीं एक रेफरेंस के साथ कनेक्टेड होगा।
ये-
या so with that maybe we can end the session here and yeah in the next class we will interact mathematical model of a system. Okay, next class we can discuss that transfer function of a mathematical model of the system. And can I get the
सर
transfer function? Just 1 minute, Abhishek. Can I get a transfer function of an accelerometer? Well, I'll have to check what the model of an what do you mean by the transfer function of an accelerometer? Like, do you have a mathematical model that you want me to get the transfer function for?
Yeah, mathematical model.
You want me to find the mathematical model for an accelerometer? Is that right?
Accelerometer. Yeah.
Okay, I can check it up and I'll get back to you.
Yeah, sure, sir. Thank you.
Yeah. अभिषेक तुम कुछ बोल रहे थे?
सर ये सर मैंने एक क्वेश्चन एक व्हाट्सएप ग्रुप में भेजा था सर, उसमें मास को दो नोडों के बीच में लगाया हुआ है, इसका मुझे नोडल एनालिसिस करना था सर, वो मुझे समझ में नहीं आ रहा।
अच्छा तो मैं वो चेक करके आई विल गेट बैक टू यू. आई थिंक आई वाजंट इन द व्हाट्सएप ग्रुप व्हेन यू सेंड दैट क्वेश्चन. I'll check it and
मैंने
I'll get back to you.
ओके
Okay. Okay. Thank you guys. You've been a lovely audience. Thanks for the interactive session. Okay, we'll meet next Tuesday, same time, 7 to 8 p.m., same link. Yeah. Thank you and hope you guys enjoy control system.